Hey everyone, and welcome back to this explainer. If you're tuning in today, you're probably looking to demystify geometry, and honestly, I am so excited to help you do exactly that. For the next few minutes, just think of me as your patient, encouraging math teacher. We're going to build your angle toolkit together, step by step.
Let's be totally honest for a second here. Do geometry diagrams just look like a messy spiderweb to you? You know when you first glance at a worksheet and just see this chaotic jumble of intersecting lines, letters, and numbers? It is completely normal to feel a wave of anxiety. It can definitely look overwhelming.
But I want you to just take a deep breath. Seriously, you absolutely don't need to panic. We are going to tackle this entire subject together by adding just one simple tool to your toolkit at a time. Math is literally just puzzle solving once you learn the rules. And today we're going to learn those rules.
All right, Section 1, the basic angle facts. Let's start with a really quick win. Okay, so this is foundational knowledge you probably already have tucked away somewhere in your brain. Angles at a single point, they always add up to 360 degrees. Why? Well, a full rotation around a single point makes a complete circle, right? So the absolutely crucial point here is if you ever need to find a missing angle around a point, all you have to do is set up a simple equation where all your known angles plus your unknown angle equal 360. Then you just solve for the missing piece. Easy.
Now, what about when those angles sit on a perfectly flat straight line? Well, a straight line is literally just half a circle. So, angles on a straight line always add up to 180 degrees. If you know one part is, say, 54 degrees, you simply subtract that from 180 to find your unknown x. See? You already have two shiny, super reliable tools in your kit.
Moving right along to Section 2, meet the parallel lines. Okay, let's really dive into this because this right here is the absolute foundation of almost all the missing angle puzzles you're going to encounter on your exams. When you have parallel lines, lines that will never ever meet no matter how far you draw them, and you slice through them with a straight line, that slicing line is called the transversal. I want you to think of this single intersecting line as a magic wand. The moment it crosses those parallel lines, it magically copies and pastes the angle patterns from the top intersection right down to the bottom one.
And because that transversal is a magic wand, there are essentially only two angle sizes on the entire diagram. Seriously, all the acute or, small angles are exactly the same size. All the obtuse or large angles are exactly the same size. And vertically opposite angles, those are the ones facing each other right across the intersection, they are perfectly equal. I know it looks complex at first glance, but it's really just a repeating pattern.
Which brings us perfectly to Section 3, the F, Z, and C rules.
Now, these are going to be your absolute best friends. They're visual memory aids that'll anchor these slightly abstract mathematical concepts into really simple alphabet shapes that you can just draw in your mind's eye. If you trace an F shape across the parallel lines, you'll find what we mathematically call corresponding angles. They sit in the exact same position at each intersection, nestled right under the arms of the F. You can also trace a Z shape to find alternate angles, tucked directly into the inner opposing corners of the Z. And here is the golden rule for both the F and the Z. Those pairs of angles are always exactly equal to each other.
But hold on, we need to be really careful here. Let's explicitly call out a super common trap that catches students out all the time. Alternate angles inside a Z shape are equal, but co-interior angles, which you find tucked inside a C shape, are not equal. They are supplementary, meaning they add up to 180 degrees. So if you trace a C between those parallel lines, remember to add them up to equal 180. Do not just set them equal to one another. Gotta keep that tool sharp.
Let's move along and see how this builds in Section 4, angles in regular polygons. So we are taking our knowledge of angles on straight lines and creatively applying it to enclosed multi-sided shapes. But before we throw any algebraic formulas at you, let's make sure we are crystal clear on the definition. A regular polygon is a closed shape made up of straight lines where every single side is the exact same length, and every interior angle is the exact same size. Think of a perfect geometric square or, a standard stop sign on the street.
And this brilliantly illustrates one of my absolute favorite geometry hacks. Polygons are really just a collection of triangles in disguise. It's true. You can find the total sum of the interior angles of any shape simply by picking one corner and drawing straight lines to the other corners, literally slicing the shape up into triangles. Since every single triangle holds 180 degrees, you just multiply 180 by the number of triangles you created. Want the quick shortcut? The number of triangles is always the number of sides minus 2. So let's neatly pack these specific formulas right into your toolkit. The sum of the interior angles is n minus 2 times 180, where n is the number of sides. But here's a really fun, beautiful little fact. If you extend the sides of any polygon to make exterior angles, those exterior angles will always sum to exactly 360 degrees. It doesn't matter if it's a tiny triangle or a massive 100-sided shape, walking around the outside always makes one full circle. And naturally, an interior angle and its adjacent exterior angle sit right on a straight line, so they will always add to 180.
All right, time to put it all together. Section 5. Solving puzzles step by step. We have all our tools, and now you and I, student and teacher, are going to work together to crack a real multi-step geometry problem. Here is your ultimate strategy to solve these puzzles. Step 1. Visually highlight the angles you already know. Step 2. Explicitly state the angle factor using. Ask yourself, is it an F, a Z, a C, or a straight line? Step 3. Do the calculation. And please, slow down here and promise me this, never, ever use a protractor to just measure and guess an angle on an exam. These diagrams are almost never drawn to scale. They're designed to test your logical deduction, not your measuring skills.
Let's do a quick warm-up puzzle. We see our parallel lines, indicated by those little arrows, and we can clearly highlight our known angle of 106 degrees. Now, if we trace the shape connecting our known angle to our mystery angle, x, we get a sideways C. That means they're co-interior. So remember our rule? We subtract 106 from 180, giving us 74 degrees for x. Simple, logical, and totally methodical.
Now, what's really interesting about this next puzzle is how we can level up our game by seamlessly combining our new angle rules with just a bit of algebra. Now, don't let the x's scare you, okay? Look at the expressions 5x minus 40 and 3x plus 18. If you slide one up the transversal to the other, you'll see they actually sit in an F shape, their corresponding angles. That means they are exactly equal. So we simply write down an equation, 5x minus 40 equals 3x plus 18. And from there, we just use basic algebra to solve for x. Work it out, and it turns out x equals 29.
And here's where the magic happens. Once we actually have that value for x, the rest of the puzzle practically solves itself. We patiently plug that x value of 29 right back into the algebraic expression to find the actual size of the angle. Then, to find y, we just look at our diagram one more time. We see that the expression 80 minus y sits right on a straight line next to the angle we just found. And what do angles on a straight line do? Right, they add to 180. By taking it one logical step at a time, we make a seemingly impossible algebra geometry mashup completely solvable. And just like that, you've conquered it. I want to genuinely congratulate you. You've essentially built your angle toolkit from scratch during this explainer, and you've mastered spotting those visual tricks like the F, Z, and C shapes. Like I always tell my students, math is really just puzzle solving, once you know the rules of the game.
So, you now have the full toolkit packed and ready to go. The rules are in your hands, the visual strategies are completely fresh in your mind. So I want to leave you with an empowering thought. When you look around at the world, where do you see parallel lines and transversals hiding in plain sight? Architecture, design, nature? You now have the power to decode them. Grab a practice worksheet, hunt down some angles, and I will see you in the next explainer.